Hi everyone, and thank you for coming to our session on client-side queries, filters, and analysis without server. My name is Ondro Batsu, and I work as a product engineer on the JavaScript API team, and I've been with the team for the last 5 years, and I will be presenting this session with my coworker Richie Carmichael, who is a developer on the JavaScript API team. So we will start this session by talking about client-side layers. Then we will talk about client-side queries, followed by filtering your data directly on the client side with the use of filters and effects. Then we will finish the session by talking about JavaScript modules that will allow you to do client-side analysis. So first, client-side layers. So when you add a client-side layer to your JavaScript application, the API will fetch all of its features at once when the layer is loaded and store all of its data directly on the client side in the browser memory. And all of the client-side layers also have uniform API, meaning that if you add a CSV layer in one JavaScript application, you can easily take this knowledge and apply it to client-side feature layers or GeoJSON layer. And because all of the client-side layers data is directly stored on the client side, we don't have to make any server-side requests when you are querying a data as user moves the mouse over the map to that intersects the polygon that we are drawing in this example here. Or also as we are filtering out the data in the application as user moves the slider thumb to change some attribute value. So all of those actions are happening directly on the client side. So because everything is happening on the client side, this should translate into fast and performant and responsive JavaScript applications. So CSV layer allows you to add data from CSV and text files as points. When you want to add the CSV layer, at the very minimum, you have to specify the URL property of your CSV layer to point to your CSV file. And if the URL happens to be the only property you specify when you initialize your CSV layer, then API will do its best to fill out all of its required parameters. But as a developer, it's a good practice to set the CSV layer parameters when you're initializing the layer. So in this example here, we're creating a new instance of a CSV layer. And we are setting the URL property to point to USGS earthquakes CSV data. We're setting the copyright. We're setting the spatial reference. We're setting the delimiter, latitude and longitude fields. We're setting the object ID field. And also we're setting the time info property on this layer because the CSV file has a field called time, and this time field contains date values. So because it has date values, I can set time info information so that I can use this CSV layer in my JavaScript application along with the time slider to visualize data over time. Okay, so let's take a look at the API reference for the CSV layer. So here is the API reference document for the CSV layer. So if you haven't used our SDK before, every class has its own API reference documentation. So in this case, it's CSV layer. And then every class will have an overview section that explains what the class does and how you can use it and what are the things to keep in mind. And also we'll give you links to the samples if there are samples, and also we'll list out the relevant classes if it's useful. Upper right hand side, you will see direct links to the constructor, properties, and methods and events of this class. So I'm going to click on the properties link, which will take me to the property overview. So this table here lists all the properties that are available on CSV layer. And I'm going to, in this example, click on a latitude field. So this will take me to the latitude field property documentation. So it's saying it's the latitude field name. And if you do not specify the latitude field property at the time of the initialization, the API will look for fields that has one of those names. So if you don't specify latitude and longitude fields at the layer initialization, but if the fields are not named one of those words you see here, then the API will return an error indicating that it couldn't locate the fields that contains longitude or latitude fields. If you are adding a CSV layer, then the XY coordinates stored in your CSV file must be in WGS84. The API uses the WGS84 as the basis to reproject your data on the fly to match the spatial reference of the view, okay? So the second bullet here actually is not only specific to CSV layer, it applies to all of the client-side layers. So if you're adding any client-side layers to your JavaScript application, then specify the layer's spatial reference to match the view's spatial reference to improve performance, okay? So for example, in a CSV layer case, if you don't set the spatial reference of your layer explicitly, then the WGS84 will be assigned to your CSV layer as a spatial reference. If you have your view in a web Mercator, then whenever you query your data or filter out your data from your CSV layer, then API has to reproject all of your CSV layer data on the fly to match the view spatial reference so that it's returning the correct result. By setting your layer spatial reference to match the view spatial reference, we are cutting out this on-the-fly projections to improve performance, and then that will help to improve the performance. Also, the things to note here is the Z values are not supported, and once the CSV layer is added, you cannot add or remove or update features. Okay, so this code snippet here is showing you how to add CSV data by a blob URL. So for example, if you don't have a CSV file, but you happen to have a CSV object like this, you can create a new blob. Then from the blob, you can create a object URL and pass in this blob URL to the URL property of your CSV layer, right? Okay, next, client-side featured layers. So you can create client-side featured layer by setting the source property of your featured layer to point to client-side graphics array, or you can pass in an empty array at the time of the initialization. So by setting the source property of your featured layer, you're telling the API that you're creating a client-side featured layer. So in this code snippet here, we're creating a new featured layer. We're setting the source property. And for the array, we're passing in three graphics. And then we're setting the geometry type, spatial reference, object ID field, and also the fields array. If you're creating client-side layers, try to specify all the required parameters as a good practice. You can just set the source property of the feature layer. Then also the API will try its best to infer the geometry type, the spatial reference, and object ID field and fields from the information provided. If information is missing, then your feature layer initialization is going to fail. So now I'm going to show you a demo on our client-side featured layers. So in this application, I'm adding the real-time streamflow conditions data from USGS website. And also we have a slider where as I move the slider's thumb, you can see the streamflow data is being filtered out based on the streamflow percentage. So streamflow percentage is an attribute field in this client-side featured layer. And as I move the slider's thumb, you can see the data is filtering out very fast. That's because we're not making server-side requests to filter the data out. Instead, everything is happening directly on the client side. So let's take a look at how this is done in a code. So when the view is loaded, we call a getData function where I'm using an Esri request object to request this data from USGS website. Then when the data is returned, then we create graphics from the data, then pass in the array of graphics to our create layer function. We're creating a client-side featured layer. Then the setup filter function will set up the slider to filter out the data based on the attribute, the streamflow percentage attribute. Then we are creating a legend, which is shown here. Okay, so here is the getData function where we are going to request the real-time streamflow conditions as a JSON object. And here's the Esri request object. We're requesting it and requesting the object to be returned as a JSON object. So once the data is returned, we call the create function method, create graphics function. Then we look through the data, we're creating a new instance of graphics and creating an array of graphics. Then we call the create layer function, passing the array of graphics. So in this function, here I'm creating the field schema. Then I'm creating a simple renderer with visual variables. Then we're creating a new instance of the feature layer. And here we're setting the source property to the array of graphics we just created. Then we're setting the fields property. We're setting the object field property. We're assigning a new render and spatial reference. Then we add the new instance of our client-side graphics to the map. So then I'm going to leave out the data filtering function for now. That's because we have to cover the concept of layer view and feature filters. So client-side feature layers support point, polyline, and polygon data in any spatial reference. And the source property can only be set at the time of the initialization. So once the layer is loaded, you can't use the source property to get graphics from your client-side layers, or you can't use the source property to add or remove or delete features from your client-side graphics. If you need to add, remove, or update features at runtime, then you have to use the apply edits method on your feature layer. Then call query features method to get the updated features or to get the features from your client-side layers. Okay, next GeoJSON layer. So GeoJSON layer allows you to add GeoJSON data that comply with the RFC 7946 spec. And if the data that you're adding does not comply with this spec, then your GeoJSON layer may not load properly. So when you add the GeoJSON layer to an application, you have to set the URL property of your GeoJSON layer to point to your GeoJSON object. So in this example here, we're creating a new GeoJSON layer and adding a USGS earthquakes data, and we're setting the spatial reference. So when you're adding a GeoJSON layer, set the layer spatial reference for performance. GeoJSON layer also supports feature and feature collections. Once the GeoJSON layer is added to your application, you can use the apply edits method to add, delete, or update features from your GeoJSON layer. So we do not support the mixed geometry types for GeoJSON layer, just to be consistent with the other layers that we support in the API. And then also the feature ID is not supported as string. This is in the works. Okay, so this code snippet is showing you how to add a GeoJSON object from a blob URL. So each implementation of the client-side layer uses the client-side query engine, meaning that whenever you query your data or filter your data, you can expect the same results regardless of which client-side layer you're working with. And given a choice between GeoJSON and CSV, choose GeoJSON over CSV. Again, set the layer's spatial reference to match the spatial reference of the view to increase for performance. Next, we're going to talk about client-side querying. Query expressions are used to select subset of features or table records from your data based on their attributes or a given geometry or time extent. Query can be done on the server side or on the client side. And different query methods are available on layer view and layer views. So and then we have a good guide document on querying and filtering your data. And this guide document talks about server-side versus client-side queries and when to use over the other. So every layer in Forex has corresponding layer view, and layer view represents a layer in the view. Now, all of your client-side layers will allow you to query and filter their data. And also here we are listing out the several client-side layers that will allow you to query and filter your data. So let's talk about those server-side layers. Okay. Feature layer, OGC feature layer, scene layer, and stream layer can be created by setting their URL properties to point to a server-side service. And when you load add a server-side layer to your Forex applications, the API will fetch or stream the features of those server-side layers on demand or as needed. And also, if you use the methods or some properties on a layer, then the API will issue a server-side request. So the examples of such methods include all of the query methods on the layer or the definition expression property on a layer. So if you use query methods or definition expression property on a layer, we are making a server-side request against all the features that are available on the service. A layer view represents the view for a layer after it has been added to a view, and layer view is responsible for rendering features in the view, and all server and client-side layers have corresponding layer views. And layer view API is layer agnostic, meaning that basically all the methods and properties on the layer views are the same regardless of which layer you're working with. So if you use the method and properties on the layer view, then those methods and properties will run against features that are available for drawing on the client side. Okay, so in the other way, layer view will give you access to all the features that are available for drawing on the client side. So whenever you call a method or property on a layer view, you're running it on the client side. Okay, so time for demo. This application has a good educational value. In this application, I'm adding a CSV layer that represents the historic hurricane tracks. And when the layer is initialized, I'm running the same query against the CSV layer and also against the layer view that represents the CSV layer. And as you can see here, the query on the layer returns about 26,000 features, while the layer view query returns about 12,000 features. And that's because the layer query runs against all the features that are available on the layer, while the layer view query runs against the features that are available for drawing. So when this application was initialized, this red rectangle represents the initial extent of the application. So the layer view ran against all the features that intersected with this red rectangle. Now, because I'm running this query against the CSV layer, all the query happens on the client side. Okay, so if you're working with the client side layers, I recommend that you run the queries on the layer because the query will run against all the features available in the layer. Another thing I wanted to point out here is the spatial reference. So you can see the layer has a spatial reference of Web Mercator, while the layer view's spatial reference matches the base view's spatial reference in this case, or the view's spatial reference in this case, which is a Web Mercator. That's because I'm not setting the spatial reference on the CSV layer when the layer is loaded. Because we are loading CSV layer, if you don't specify the spatial reference, then spatial reference is set to WGS 84. Now, if you run the query on the layer here, then API has to reproject the data on the fly to match the spatial reference of your view. And as for the layer view, for any layer view, the geometry stored in the layer view will match the spatial reference of the view. Okay, when can you run client-side queries? So whenever you are working with client-side layers, you are always running your queries directly on the client side. If you're working with server-side layers, then you need to run the query against the layer view that represents the server-side layer in order to run your query on the client side. So like I mentioned earlier, if you're running your query against your layer view, you're running the query against the features that are available for drawing on the client side. So all of those layers and layer views have 4 different query methods. You will see them, all of the layers and layer views that we mentioned here. Query features method returns the subset of features that meets the requirement. Query feature count method will simply return the number of the feature that meets your requirements. Query object IDs will return an array of object IDs that meets the requirements of your query again. And query extent will return an extent that covers all the features that meets the requirements. Okay, so quick demo on querying features. Okay, so in this application, I'm adding a CSV layer that shows the areas that are managed by the National Park Service. I downloaded the CSV file from the National Park Service website. And this CSV file has a date field that tells when the protected area was established. So I took advantage of this date field and set up a time info information on the CSV layer when I load the CSV layer into the application. Then I also added the time slider widget, and then as you navigate through time on this map, you can see that the parks that were established for that given year are highlighted on the map. So for example, in this case, you're seeing all the parks that were created in 1923 highlighted on the map. And then the grayed out national parks were created before 1923. And then all the parks that are established after 1923 are still not visible on the map. Okay. And then on the upper right hand side, you see links to the national parks that are created in 1923. And I'm doing this by querying the data. So here I'm adding the new CSV layer. I'm setting the time info property. I'm setting the start field to the date field that's coming from the CSV layer, setting the interval to 1 year. I'm also setting the pop-up info. So if I go click on a national park, you will see the national park information. The title is coming from the unit name field, coming from the CSV file. And I'm also setting the content to show the established date. And also I'm reading the value from the description field, which is over here. Okay. Then I'm also setting a simple renderer, and I'm setting a sim symbol for the simple renderer, which are the trees you see on the map. Then I also set the labeling information on the layer. Then I add the layer to the map. And as you can see here, actually I have a view for the lower 48 states, then I have view for the Alaska and view for Hawaii, okay? So I have 3 different views, and I'm adding the same CSV layer to those 3 different views. So now when the view is initialized, I call the animate parks and filter states function. So let's take a look at animate parks function here. So here is the animate parks function. So in order to get the layer view instance that represents the layer, you need to call the whenLayerView method on the view, pass in the instance of the layer. Then when whenLayerView is resolved, then it will return the instance of the layer view that represents the layer. So now you have the instance to the layer view. So what I want to do here is I want to set the definition expression and different effects as the time slider's time extent changes. So here I have a block of code where I'm watching the time extent property on a time slider. Then I'm setting the definition expression on the CSV layer. So here you can see I'm setting the definition expressions to say, okay, show me all the national parks that was established before the current time extent. So you see all the layers there, gray and highlighted. Then also I call the set layer effect function and pass in the layer view instance. So using the layer effect, what I'm gonna do is basically I'm gonna apply 2 different sets of effects to my features. Okay. So if the features were established before 1923 in this example, I'm gonna apply this gray scale, and then I'm gonna blur it out a little bit. But if the layers were created in 1923, then I'm applying this bloom effect. So you see those really bright green points on the map. So I'm not gonna spend more time on a feature filter because Richie's gonna cover this in detail just in a bit. Okay. So then what I do is I get the layer view instance, call the effect, and then effect has a filter property. In this case, we are setting a time filter on our layer view, and then I call the create query method. So create query method will create a query object that meets all the requirements of the filter that we set on a layer. Then on a query also I set actually the order by fields property, and I'm gonna order the results of my query based on the established date field. Okay. So then I'm actually passing in a query to the CSV layer query features method. So I'm running the query on a CSV layer rather than a layer view. Then once the results are returned, I'm looping through the results, and then I'm populating this list here with the links to the national park information. Okay, quick few words on query tips. And those tips will mostly apply to server-side layers because you have the choice to run the query on the server side versus on the client side. So if you're working with a large server-side layers and speed and responsiveness is absolutely important in your JavaScript applications, then run the queries on the layer views that represent those server-side layers, as the query will run on the client side. If the geometry's precision is important to you, then yes, run the query against the server. So for example, if you want to make sure you get all the features that intersect a given polygon, then run the query on the layer, and that will make a server-side request, and then that will run on the server side against the original geometries stored in the service. As if you run the same query on the client side, the results may not be precise, as the features that are stored in the layer view are optimized and generalized for drawing. Okay. Also, if you need to run the query against all the features that are available on the feature or the service, then run the query on the layer, because layer view query will only run against the features that are available for drawing. So this concludes my session, and I'm going to hand mic over to Richie. Richie?
Thank you, Andro. My name is Richie Carmichael, and I'm a developer in the JavaScript team, and I'll be talking about client-side filters and effects, and also client-side analysis. I'm going to start by talking about filters. Filters are a way of hiding features that do not satisfy a criteria, and those criteria could be based on spatial, aspatial, or temporal conditions, or a combination thereof. And these filters are applied client-side within the browser. That means that there's no additional communication to the server. And because they're client-side within the browser, they're relatively fast. They're very fast, in fact. And in the snippet shown in the bottom of the screen, you see an example of a filter being applied to a feature layer view. And it's various ways of applying spatial, temporal, or aspatial filters. Effects are similar to filters, where filters can hide features that do not satisfy a criteria. Effects can apply visual effects to included or excluded features. And this can be used to both accentuate or de-emphasize features based on a certain condition, criteria. And here's an example here. I'm applying a filter to a feature layer view. In this case, it's earthquakes. And we're saying for those earthquakes that are not larger than 7, we want to make them semi-transparent. Apply a grayscale and make it 50% transparent. So basically, we're graying out smaller earthquakes. Here's another screenshot. Again, it's earthquakes. And what we're seeing in this app is that most recent earthquakes are shown with a yellow dot, and all historic earthquakes are grayed out. And so in this case, it's very useful because we can see how recent earthquakes compare to all historic earthquakes. We can look for a spatial trend here. These links to the source code and also the live app in the bottom right-hand corner. And now I'm going to go through a live demo which shows both filters and effects and how to use them within an application. This is a demonstration of using filters and effects within a web mapping application. On the right is a web application running locally on my machine, and on the left is a source code to the application. Each dot represents COVID-related information per country, and in some cases like the US, it is per county. So just scrolling through the source code on the left, I want to show that this is a section that is creating a new feature layer. Each point is symbolized with a red dot, and that layer is added to a map with a dark gray background base map. And then the map is added to a 2D map view. And by default, we zoom into the current extent. And the next line here, we get the feature layer view. This is the layer view of the feature layer. And we'll be using the layer view to apply filters and effects. So as is, the app doesn't really do much. But what I want to do is apply a filter related to my mouse cursor. So I'm just uncommitting the code. I'm going to refresh the browser. And what this does is that it applies a filter for a 300 kilometer radius around the mouse cursor. So now when I move my cursor around, I only see those points from the feature layer that are within 300 kilometers of my mouse cursor. So that's a filter being applied to hide certain features. Now we look at an example of using an effect. And the difference of using an effect is that we can apply visual effects to included or excluded features. In this case, we want to apply an effect to those excluded features. So for those points that fall outside the 300 kilometer radius, we want to make them semi-transparent. So again, as I move my cursor around, those features that are beyond the 300 kilometers are shown as semi-transparent. Okay, so go to another example. This time we want to apply an effect to the included features. So those features that are close to my mouse cursor, I want to invert the color, but also apply a bloom effect, which is similar to like a glow effect. So now when I move my cursor around, you'll see that the red dots are inverted to become blue, but also they are glowing with the bloom effect. So these are visual properties. The last step I want to do is use the feature layer view to perform a client-side query to actually show something informal. Namely, I want to summarize the number of cases and deaths that are within this 300 kilometer radius. So refresh the browser. So now when I move my cursor around, at the bottom of the screen, I can find out the number of people affected by the coronavirus that are within 300 kilometers of where my mouse is right now on the screen. That was a demonstration of using filters and effects. Be sure to click on the links on the right hand side to view the live application, but also the source code. Now we're going to move on to client-side analysis. We're going to explore the use of 3 libraries that are available in the JavaScript API, the geometry engine, the projection engine, and also the geodesic utils. First, the geometry engine. This is a library or a module containing 30 client-side methods. And these can basically be grouped into 3 types of methods. The first group are those which produce new geometries like the buffer or the clip. Those that return a boolean or a true or false. For example, does like the contains. Does one polygon contain another polygon? Is a point within another point? Or do 2 geometries intersect or cross each other? And the third set of methods are ones which return a value, like an area or a length of a line. And there are basically 2 flavors of the geometry engine. One that computes, does these computations synchronously, and another library that does these computations asynchronously. The methods are exactly the same. The difference being is that the asynchronous performs the computations in a separate thread. So the asynchronous one is probably better if you have a more intensive computation that you may want to run, so that you don't lock up the UI thread. But for smaller jobs, your quicker ones, you can just use the synchronous methods on the geometry engine. Here's an animation of an example. Here we have a web app that the blue polygon is interactively dragged around the screen. And when that blue polygon intersects the yellow polygons, which I think radiuses around schools and railings, when they intersect, the blue polygon changes color. So this contains or intersects method is performed every time or as the polygon's being dragged around the screen. Traditionally, we've done these sorts of computations using a geometry server. This is a remote server that we send instructions to compute these types of things. That is still possible using the geometry server library or module. We can send instructions to be computed remotely. The advantage being is that if you have a very complex operation, you can send it to the server to do all the hard work on the server, and you just wait for the response to be returned. The disadvantage, of course, is that you have to compete with network latency. You have to wait for it to be sent, and you have to wait for the response to be returned to the browser. Here's an example of what we did before by sending a geometry to the server and waiting for the response, that being the length of the line that we sent. So basically it looks the same. The difference being is that we're sending the request to the geometry service for computation. The second library we'll talk about is the projection engine. This is a module that we use to project geometries between coordinate systems. It is based on the same code that is used in runtime and desktop. It's used as a WebAssembly. This is a technology that basically the code is compiled to a binary. For that reason, it does take some time to load the projection engine into memory, so you may want to use it sparingly. And as such, we do provide a method for the user that is loaded as a way to test whether the projection engine has already been loaded. Example, we have some polygons that are in the equal Earth Greenwich projection, and in this animation we're projecting those country polygons to the world fuller projection. And here's a snippet basically showing how that is performed. So what we're doing is we have a collection of graphics for every country. We clone those graphics and then we just update the geometry using the projection engine to project from one coordinate system to the other. And the third and last library is the geometry utils. This is for performing computations, specifically geodesic computations. And there is some redundancy to methods in the geometry engine, as you can see in the list here. The main difference is with the geodesic utils, it supports any geographic coordinate system, including non-terrestrial systems, whereas the geometry engine only basically supports WGS84 and Web Mercator. Here's an example of the geodesic utils being used to compute the area of the Bermuda Triangle. So in this snippet, we have three locations, the triangle, so to speak. We create a polygon from those three locations, and then we use the geodesic utils to find the area of the triangle. And then we just console out, we print the area to the console. In this case, we compute the Bermuda Triangle to be over 1 million square kilometers. Another example, this time on Mars, where there are two rovers, Curiosity and Opportunity. We want to find the distance between the two rovers on Mars. So again, based on the two locations, we create a polyline, and then use the geodesic utils to find the length of that line. The next method, geodesic density, is used to densify that line. And the reason we do that is because in this example, we want to show a curved line. So we want to add vertices to the polyline so that we can render it on the screen. Lastly, we're just printing the distance to the console. But in my next screenshot is the actual app which that code has been used. If I go back in the bottom right hand corner, we have links to the app, live app, but also the source code. So this is a screenshot of the app where we have the densified line, the red dotted line, and also displayed as a label is the length or the distance between the two rovers, 8,500 kilometers on Mars. That concludes our presentation. We appreciate you listening and watching. We look forward to your feedback. Thank you.
Hi, good afternoon. I'm Jan Keben. I'm a developer on the JavaScript API, and you just saw a presentation by Richie and Andrew that are here also, and I'm gonna be asking your questions to them and to myself as well. So the first question we received is there any performance benchmark to consider the number of features to load at client side? For example, loading 100,000 features across the layers would slow down the map loading first time. So we don't have benchmarks. It really depends, you know, if you have, we don't have benchmarks because it really differs. The result would differ if you are on a mobile device, on a desktop, and it would differ also if you have like one layer or many layers. I don't think, so what you have to see is that lots of those layers, like the GeoJSON layer or CSV layer, they load the features inside a web worker. So it keeps the web app very performant, and it won't impact the performance so much to load very big data sets. But of course, after you have to consider also the memory usage. So if you have 100,000 points, it's not a big deal. But if you have 10 layers with 100,000 points, it might impact. So yeah, no, it's just like it's based on your use case. You have to check how your app is responding. If you want to manage better the loading, you can eventually load the layers progressively, one by one, and so on. The next question is by Nick for Richie. One functionality I am really missing. We can do feature layer view highlight, but there is no get highlights, meaning that if we don't have the handle because some other components has done the highlighting, there is no way to get the selected features, right?
Right. So currently it's not possible, but it's something that we are considering, the ability to find the features that are currently highlighted. So that could be coming.
Okay. We have a question for Andrew. How to query features by selection?
Hi, so I may not be understanding this question completely. If I do not answer your question completely, then please find us on Ask Our Expert section in the web development channel. I would be happy to help you more if I do not answer this question correctly. So I believe the user is asking how to select features maybe based on polygons or extend something that user draws on the map and select the features on the map. So we have a sample in the SDK. The SDK sample is called Highlight Features by Geometry. And shortly, I will put a link to that sample in the answer section. And if this doesn't answer your question, like I said, please come and find me on Ask Our Expert section, channel.
Richie, do client-side queries and analysis use credits?
Great question. No, they do not. They do not consume any credits. So this applies to all the analysis you saw today. That's the projection, the geometry utils, and the geometry engine. They do not consume any credits whatsoever.
I think we have a related question also. I can't understand in my JS API app can be independent from online connectivity after everything is downloaded in memory. I would like to believe that it is possible, but I am not sure. Can you answer that one as well?
Yeah, you should. Yeah, so it's independent of online, so you can continue to do everything disconnected. You don't need to do any sort of access to a server. So all the work is done locally in the browser.
Nice. So I will take the next question. Can the content of graphics be loaded by the JS API and then operated on the client side rather than having to write the code to create the features ourselves? So I guess you are referring to modifying the graphics that are in the feature layer. So when you create a client-side feature layer, you can pass an array of graphics which represents your features. Then those features, they are transferred to a web worker. It's a light thread. We don't have access to them directly. We have to communicate through messages to that web worker. The advantage is that you can store a lot of features in that web worker, and you can then perform very complex queries and analytics on these features, but we can't directly modify them. So every time you want to modify the client-side query, the client-side features, once the layer is loaded, you need to always use apply edits. If in future we see an easier way to do it, we would, but like it's a very different from 3x where you have access to the graphics and then modify the geometry. Like we can't do this anymore. With the benefit that we can, perform very heavy queries and that doesn't impact the responsiveness of the application. We have a general question. Can we get access to the slides and sample code?
Yes, this presentation will be available as a streaming video and the PowerPoint shortly after the end of the conference. And the PowerPoint will have links to the samples we've shown, and also where we've shown live apps, there'll be links to those as well. In the meantime, if you need anything else, you can surely contact any of us through Ask Our Expert, so we can provide any links that you need in the meantime.
We have a question for Andrew. Can you load a feature service layer into a client-side layer?
Yes, the short answer is yes. You still will have to create a new instance of a new featured layer, point to the service endpoint, then call the load method on the feature service layer. Once the layer is loaded, then query the features from the feature service using with a word clause 1 = 1, fetch all the features. Once all the features return from the query, then you can load those returned feature sets into a client-side feature layer. And if this isn't clear, then again, I'm going to refer you back to Ask Our Experts section. Come and find me there, and I can provide you with a simple code pen that shows you how to do this.
Thank you. We have a new question. At the moment, feature table widget seems to point to the service rather than the features that are in the layer views. Is there a way to handle feature table data on the client side? Do you know, Andrew?
I don't know exactly, but I believe, yes, they are pointing to the layer data instead of the layer view. If there are plans, I don't know. Bill Schlatter, I will find you later after this presentation. I'm going to talk to the dev for the feature table widget, and I will get you the full answer for this.
Next question. I will take this one. Can we query features within a cluster on user click? So that's a great question because it's a request that, yes, it's going to be possible with the upcoming release of the JavaScript API. It will be part of the release notes. I can't show it to you right now, but yes, there will be an example to show query the extent of a cluster, to query the features inside a cluster, and also in that example, how to create a convex hull of all those features. And then the example will show, a pop-up. Basically, you can click on the cluster and then after browse the individual features on inside that cluster. Andrew, there is a question about CSV layer. Does the CSV layer allow to escape for escaping of delimiters?
Yes, CSV layer supports escaping of characters, and if for some reason, if it's not working, then again, find us, we will get it fixed, but it does support and should work.
Richie, question about the client-side projection engine. Does it support WKT projection strings, or is it restricted to projections which have a WKID?
Both are supported, so you can define your space of reference using the ID or the well-known text. There is one thing that important to note, that the client-side projection engine only supports analytical data transformations, so it does not support grid-based transformations.
So we have a question. Okay, so we have a question for Andrew. If I am adding graphics on the client-side feature layer at runtime using apply edits, it will generate a new object ID, even if it already has one on each graphic ID. Is there a way to add graphics at runtime without changing object IDs already present in the graphic?
This cannot be done presently, unfortunately. Every time you do call apply edits on a feature collection, object IDs are changed and updated, and we are aware of this behavior, and we are definitely looking into persisting the object IDs for feature collection through apply edits. So hopefully it will be coming sooner.
Yeah, it's we already have the issue for it, and Andrew assigned it to me, so it's really all relying on me to implement the fix. So we have a question about the SQL. So does the ArcGIS API has a built-in SQL generator? So I think you mean parser. The JavaScript API can parse the SQL. It's a standard SQL, the same as used in ArcGIS Online. So when you do a client-side query, we parse the SQL and execute it against the client-side data. And then if you have a geometry, we use the geometry engine, the client-side geometry engine to also perform the operations on the client. The SQL parser is available inside the API as it's public, and I will post a link in the below the question. It's Esri core SQL, I think.
Yes.
Yes. Okay, so let me ask. We have a new question for Richie. Do geographic client-side queries work for areas crossing the entire meridian?
What was the question?
It's the last one. Do geographic client-side queries work for areas crossing the entire meridian?
I believe they do, right? I think so.
Yes, they do.
We received a new question that I will answer from Steve. When calling layer view, will the return value be the same reference, or it can be different? When you call when layer view, you will get always the same layer view every time you get. Yeah, it's always the same layer view for a layer inside a map view.
And there's a question about the Bermuda Triangle example. Can the geometry service be used? And the answer is yes, you can do it. Of course, the disadvantage is that you have to wait for the response from the server, but it is definitely possible.
Okay. We have no more questions. If you have any.
I think there's one question. When I call layer view query features with a query that has extend, set to view extend, do we answer this question?
No. Yeah, go for it.
Why do we get more features or points than I see on my screen? So this, you should not be getting more features. I think I need more details. So for example, if you have filter set on your layer view, then just setting the query parameters on your own without honoring the filter you set on layer view, then you could be getting more points or features that does not honor your filter, for example. So for example, if you have filter set on your layer view, then you can call create query method from your filter, then pass that query parameter to your query features method. But if that's not what you're doing, then again, I'm gonna ask you to come and find me in the Ask Expert section in the web development channel. And I'll be happy to help you with additional questions.
All right, thank you very much for attending.
Yeah, thank you very much for coming to our session. Again, I repeated this many times. If you guys still have more questions or think of more questions after this session, we'll be around to help you and answer your questions you have for client-side features and within GIS API. And thank you for coming.